All right, so in this video, we're going to take a look at determining the point-slope form of a line, and we're going to work with the examples we did in the previous video. So our point-slope form of a line is just a general equation involving the slope of a line and a point, x1, y1, on the line. So if you recall from algebra, your slope is y2 minus y1 over x2 minus x1. Now, we generalize our equations with y's and x's. You remember like y equals mx plus b. And then x1 and y1 is just any point that's on the line. So using this variation on the slope formula from your algebra days, if we multiply both sides by the denominator, that's going to clear out the fraction. And we're going to get the slope m times this denominator of x minus x1 equals our numerator of y minus y1. And if we want, we can just rearrange the left and right hand sides. And here is our equation for our point slope equation for a line. So we have y minus y1 equals m times x minus x1. All right, so for example 3, write the point-slope form of the equation of the line connecting the points from the function from example 2a. We'll use the 3 and f of 3, or negative 5, because it's easier than doing decimals. But again, you could use the 3.01 and the f of 3.01, whatever that comes out to be. So f of 3 is negative 5, and sometimes it's just better to use the easier numbers. And we found the slope of the line in example 2a to be 1.01. So we want to find the equation of a line in point-slope form that goes through the point 3, negative 5, and has a slope of 1.01. So if we do y minus our y coordinate is negative 5 equals 1.01 for m times x minus our x coordinate of 3. And just like any math teacher will tell you, when you have minus and negative, you usually want to clean it up a bit and make it plus a positive. So here we have y plus 5 equals 1.01 times x minus 3. And we're going to take a look at that visually right now as well. All right, so for this example, if we take a look at the graph of x squared minus 5x plus 1, and then we look at the point 3, negative 5, which the output when x is 3, when the input is 3, our output is negative 5. There's that point here. We calculated the slope in example 2a to be 1.01, and so now we're going to write the equation of the line that goes through this point with this slope. So in point-slope form, it's going to be y minus, or y coordinates negative 5, so we could put minus and negative 5, but always want to clean that up with a plus 5, equals our slope 1.01 times x minus our input of 3. And there we go. So if we zoom in, it kind of looks like it's almost, the more we zoom in, it's kind of merging into the graph itself. I mean, it starts to spread out a little bit, but and if we zoom out, we can see, but there's that right there. All right, so for example 4, we want to write the point-slope form of the equation of the line that passes through the point 3, f of 3, or 3, negative 5, with the slope that we found in our answer in example 2d. So if you recall from that, we found that slope to be 1. Those values 1.01, 1.001, etc. As the x-coordinates got closer, those slope values, when we found the average rate of change, those got closer and closer to 1. So let's go ahead and write y plus 5, we know, minus a negative is plus 5, equals 1 times x minus 3. And because the slope is 1, you don't have to write the 1 in front. You don't need the parentheses either, although I would not mark you wrong if you left it in this form. I just always want you to clean up the minus and negative as plus a positive. So we have y plus 5 equals x minus 3. So let's take a look at what that graph will look like with the original function as well. Okay, so now if we take a look at, for example, 2 part D, where we found the slope to be 1, if we replace our previous slope with a slope of 1, we get this graph here. And notice, again, as we zoom in, the graph kind of merges in a little bit with the original function graph in blue. And something you're going to talk a lot about in calculus, especially calculus 1 or AB calculus, is what's called a derivative and a tangent line. So in this case, we have what's called this line here is a tangent line to this curve in blue at this point 3, -5. And what a tangent line is, you may remember from geometry class and dealing with circles in geometry, is it's a line that hits a curve at one spot and one spot only. And so this line here we have in black, the y plus 5 equals 1 times x minus 3 line, hits this blue curve at exactly one spot when x is 3 and y is -5. So you'll be talking a lot about finding this equation in calculus.